In the last video, we talked about lines, which are covered in section 1.2 of the textbook. This same section also covers parabolas. Recall that a parabola's equation looks like y equals ax squared plus bx plus c. If a is positive, then the parabola opens upward. If a is negative, it opens downward. The most important features of a parabola are its roots and its vertex. When a is positive, the vertex is the lowest point on the parabola, and when a is negative, it's the highest point. The method for finding the vertex of a parabola is called completing the square, and it will come up occasionally in Math 151 and Math 152, especially in sections 5.8 and 7.1. So it's a good idea to review that in section 1.2 of the textbook. But finding the roots of a parabola, or of a function in general, comes up much more frequently. For parabolas, we have two methods for finding the roots. We can use the quadratic equation, or we can factor. Here's the quadratic equation, which you can also find at the bottom of the algebra box on your Precalculus fact sheet. Notice this quantity under the square root. b squared minus 4ac is called the discriminant. It lets us decide whether or not a parabola has 2 roots, 1 root, or 0 roots. Notice that when the discriminant is 0, that single root is the same place where the vertex is. You don't have to complete the square because the parabola already is a perfect square. When the discriminant is negative, that means the parabola is either entirely above or entirely below the x-axis. It's important to be able to use the quadratic equation because you won't always be able to factor the equation for the parabola. If there are no roots, it won't factor. However, factoring is much more useful in general. The quadratic equation only works for parabolas. So we're going to practice factoring first in this simple case for parabolas, and then look at a few more complicated examples. The basic principle of factoring is that if you have a product which equals 0, then one of those factors also equals 0. That means that if you can get an equation into the form 0 equals something, and then factor that something, you've reduced the problem into many simpler problems. Here, in this example, we had this weird product that we don't understand, and now we reduced that equation into 3 simpler equations. Either sine of x is 0, which means x is a multiple of pi, or the natural log of x is 0, which means that x is 1, or x squared minus 3 is 0, which means x squared is 3, so x is either plus the square root of 3 or minus the square root of 3. If you didn't remember where the roots of sine x or ln x were, don't worry, the next 2 videos are going to cover these topics. Now let's try to use this basic principle of factoring to find the roots of a parabola. Where are the roots of the parabola y equals 2x squared plus x minus 6? Pause the video for a moment to think about your answer. We want to solve the equation 0 equals 2x squared plus x minus 6, and our strategy is to factor it into these 2 linear terms. Whenever you factor something, it's a good idea to multiply back and check that you get the original thing. Now that we have these 2 factors, we set each of those equal to 0. These linear equations are much easier to solve, and we see that either x equals 2/3 or x is negative 2. So if we graph this parabola, we know where it hits the x-axis, and we also know that since the leading coefficient 2 is positive, it's going to open upward. That tells us it looks something like this. If we also completed the square, we could find the vertex and get an even better picture of what this parabola looks like. Use factoring to find the roots of the parabola y equals minus x squared plus 4x plus 12. Then sketch the graph. It might help you to start by factoring the minus sign out. You should have gotten that 0 equals negative x minus 6 times x plus 2. That means that the roots are at x equals 6 and x equals minus 2. So when we go to sketch the graph, we already have 2 points. Additionally, since the leading coefficient is negative, we know the parabola is going to open downwards. If you were able to complete the square, you should have gotten y equals minus x minus 2 squared plus 16, which means the vertex is at 2, 16. That lets us complete our picture. Now let's try something a little trickier. Consider this equation. 4r times r squared minus 9 equals r plus 2 times r squared minus 9. Pause the video and think about how you would solve this. It's tempting to just cancel out the r squared minus 9. That leads to the equation 4r equals r plus 2, and so r is 2/3. However, when you cancel something out, you really have to consider the possibility that that thing being canceled is 0. Another way to think about this is what would happen if we moved everything in this equation to one side. Now if you factor this, the r squared minus 9 comes out, and everything else lumps together into the factor 3r minus 2. The r squared minus 9 itself factors further into r minus 3 and r plus 3. That's called the difference of squares. You can also find the difference of squares equation near the top of the algebra box on your Precalculus sheet. We're going to use this equation a lot in section 2.5, along with another equation called the difference of cubes. We used the difference of squares here to reduce down to 3 linear factors, and since 0 equals their product, then we know one of them equals 0. So either r is 2/3, or r is 3, or r is minus 3. So there are 3 solutions, not just that one solution we got by hastily canceling out r squared minus 9. Here's another tricky equation. Pause the video and try to solve it. If you get stuck, try to find a common factor on these 2 sides of the equation. We start by moving everything to one side of the equation. And now, when we factor further the r squared minus 1 and the r squared minus r, we notice that they share a factor of r minus 1. So we can pull that out of the entire thing. Now what's left doesn't have any common factors, so there's nothing to do but multiply them out, subtract, and then try to factor the resulting thing. When you do all that, you should get 2 times r plus 2, r minus 1, and r minus 1 again. Even though there are 3 linear factors here, we only get 2 solutions. R is negative 2, or R is 1. That's because one of these factors is repeated. You have to be a little creative here to notice this shared factor of R minus 1 instead of just multiplying everything out and combining terms. Factoring can be a tough skill to learn. It's a good idea to get some more practice now at the beginning of the class. Please go on to the next video where we will discuss logs and exponential functions.